all and welcome to my YouTube channel. So today in this particular video, we are going to see how we can utilize Langchain with Gemini for text generation and for multimodal capabilities. And also we are going to see how we can build a retrieval augmented generation, that means RAG, based on our own PDF document. So we are going to use Langchain with Gemini and we are going to build a RAG application using Gemini, and we are also going to use the generative AI or Google's embeddings for doing an embedding retrieval for our RAG application, right? So let's just get started. So essentially, if you want to work with Langchain using Gemini, you want to install the dependency called Langchain Google Gen AI. So Langchain inherently didn't bring up this Gen AI internally into their Langchain by default pip install library. They have provided it as explicit library to integrate with Google Gen AI. So hence you need to install this dependencies along with Langchain, and you have to also install other dependencies like Google Generative AI and ChromaDB for RAG applications and PyPDF for RAG applications. So these are dependencies that you need to install for this notebook to work into play. And important is Langchain Google Gen AI to use Langchain with Gemini, right? And then these are some utility functions that we're gonna use to visualize the output in a better visual representation way, right? So we are going to use the markdown and also we are going to use display methods to better visualize the things out. So let's just run this cell, and also we are going to import generative AI from google.generative AI, and we are going to use Colab's inherent library to use the Google API key, that is Gemini API key, that we have already created here in this notebook. We have already stored it here in this notebook. So if you wanted to know from where we gonna get this API, you can go into the makerstudio.google.com, and I have explained all of this stuff in my past videos. So you can go and watch it, and you can also get to know in depth about what is Google Studio, what is Gemini AI, how we are going to use the Gemini AI. So there are a lot of things that I've talked about in my previous video. You can also go and see it. But if you wanted to get into the API, you can just go into this makerstudio.google.com, and you can get into the get API key. And once you click on that, you're going to create a API key, and you can also utilize the previous key, and you can install it here in your Colab. You can mention it here, and then you can use this google.colab inherent library, and you can call this API and establish it into your Gen AI configurations. So that is what I'm trying to do here. So I'm using user.data.get Google API key. So it will just get my Google API key from the notebook that I mentioned, and then it's going to configure it inside the Gen AI, right? So let's run this cell, and then once the things are set, then we are going to use the generative AI capabilities to generate the text. But right now let's revise something what we have seen in my last video. So I use Gen AI dot generative model with Gemini-pro model, and I used it with the default Google's library, and use model.generate content with the query to generate the response. But I'm going to do the similar thing with Langchain. So for that you have to import chat Google Generative AI from Langchain Google Generative AI, and then you're going to specify the Gemini-pro model inside this Google Chat Generative AI, and you have to mention the Google API key, and that will set up your Google Gemini-pro with Langchain, and then you can start making queries into the LLM. So you're going to use llm.invoke, and then you're going to pass in the same function or the same query, and you're going to get the results out of it. So it's the same use case, but I'm trying to show it using Langchain. So here you're going to use it as chat Google Generative AI, and essentially previously you were using a generative AI generative model functionality from Google's generative AI library, right? Now, this integration with Langchain is gonna help us in building a lot of applications, and that's why it's always feasible to use uh, Langchain or any other independent libraries for betterment of your applications, and also you can use it for your generic purpose, or you can build a lot of good applications out of this. So instead of using the Google's generative AI library. You can use it, but if you wanted to get more capabilities out of your LLMs, you can start using the integrated versions of Langchain with Gemini AI, right? So here are the results that you're gonna see once you make a query using Gemini-pro using Langchain, and then you want to see the text generation has been done. Now the next thing that we can use Gemini is using Gemini-pro Vision, which uses image and a text to describe something about an image. So essentially, let's say I have an image which is all about a t-shirt. So I'm going to make a call to describe the t-shirt. Like I wanted to describe that this product's t-shirt, and describe its appearance and a kind of a product description of this particular t-shirt for my use case, right? So that's what I'm going to do here. From langchain.core message, I'm going to import human message, and also from Langchain Google AI, I'm going to import Google generative AI, and then I'm going to mention Gemini-pro Vision. It's as simple as what we did above, and then in human message I'm going to mention two type of content. One is text content, and another type is image content. So for the text content, I'm going to mention a query for that particular image. So I'm trying to set up a query like write a short description about the product shown in the image for mentioning it on the e-commerce website. So this is one query that I'm posting, and with this query I'm going to submit an image. So I already have this image available in my Colab. So I'm going to pass this image URL with type image URL, and just going to pass it with human message into the LLM that we are going to use. So I'm going to use LLM as Gemini-pro Vision, right? So with this I'm going to do llm.invoke. I'm going to pass this message that I mentioned here, and then it will try to serve me the best description for this particular image, right? So this is how you do it using Langchain, and we're going to use this uh, for our different use cases, but this is what it brings in with Langchain. You can also pass a direct image or image URL from the Google or any of the website, and what it will do is it will download the image, and then it will process uh, your prompt, and then it will give back your answers. And you can also use base64 image. You can pass it here, and it will try to do a decoding, and then it will get you an answer back. So there are different ways you can try it out, and you can mention it here, and you can get your answer back using the image and the text. So you can see it has written the answers, the description about particular image that I asked for. So this is men's t-shirt is perfect for showing off your love of sport. The t-shirt is made of soft and comfortable cotton blend and features a bold eye-catching design. I think it looks good. This description looks good. We can utilize it for our use cases. So this is one of the generic purpose that you can use it, and you can build more of it from here. So let's see one advanced use case that we can build it right from by using Gemini. So what I'm trying to do here is I'm going to use this Gemini and trying to build up a RAG application where I'm going to take up one PDF, and I'm going to chat that particular PDF. I'm going to get some answer from that particular PDF, and trying to do using different retrieval options that are available in the RAG, right? So let's explore different retrieval applications that are available with generative AI embeddings that is available from the Google. So we are going to use that. So this is one of the applications that I'm going to bring up. So this is one of the summarized way. So what I'm going to do is I'm going to take up this particular PDF. I'm going to split that into chunks. I'm going to split all the text in the PDF into chunks, and then I'm going to embed it into the embedding space using generative AI, Google's generative AI models, which is capable enough for generating the text embeddings. And then I'm going to store all of these embeddings of the chunks into this vector database, right? And then what I'm going to do is I'm going to put up a query. I'm going to put up a query, and I'm going to embed that particular query and do a similarity search using the vector database similarity search option, right? And then I'm going to find the nearest documents or the chunks which are nearest to the question or the query that I pasted here. And then this particular retriever will gonna send me a set of documents or the text from which the answers are very close to the query. And then I'm going to pass this set of documents or the text to the LLM with the question that I gave to the that I gave while searching a similarity search. And then I'm going to pass this question and the list of the documents or the chunks into the LLM, that is Gemini. And that's where the Gemini will come into play to concise or give me the results or answer that I'm looking forward based out of the questions that I have put it up in this particular application. So this is all the this all whole setup will resembles the RAG application, and it can be made more complicated. But right now I'm just trying to show up an easiest application just for understanding the purpose and where we can utilize the generative embeddings, and also where we can use Gemini AI Pro for chatting with your PDF, right? So this is a application that we're going to try it and build it up here. So for that, let's install some dependencies that are required. And once these dependencies are installed, we are going to load some of the uh, requirements with the Langchain. So we're going to use prompt template to build some prompts that are required, and we're going to use PDF loader to load our PDF. And then we're going to use recursive character text splitter to split our PDF documents or the text in the PDF document into certain chunks. And then we are going to use Chroma vector database. We can utilize any vector database. I found Chroma to be very easy to be explainable here. You can also use Qdrant. You can also use uh, other databases of like FAS, and then you can also use retrieval question answering chain. So let's see how we can use all of this functionalities from Langchain, and also use Gemini with Langchain to make sure that we are able to build some application out of it, right? So let's just run this cell, and then we are going to uh, re import the things from Langchain Google AI. And then we are going to uh, enable the model, which is Gemini-pro. We are going to pass the Google API key, and then we are going to set the temperature to 0.3, and you can also reduce it to 0.2 so that the model doesn't become a very generative, or it shouldn't become very produce a random results, right? I don't want it to be very constructive. I want to be model to be very specific answers, to give very specific answers. So that's why I'm reducing the temperature. And I'm going to set up this convert system message to human true. And then once this is done, your model is set up, and then you can use this model for your LLM use case that I have shown in the image, right? So now next thing is to load up your PDF. So I'm going to use a PDF called attention is all you need. So maybe you are all aware of this particular paper where this paper talked about the details of transform model that generally being used, right, in all the NLP application. And since here the things changed around in the NLP, right? So I'm going to take the paper attention is all you need and going to split up into the pages, and I'm going to show the content of this page. One is the third page of the content. So this is the content from the third page from this particular PDF. And this PDF has almost like 15 to 16 pages. Let me just print that out also. So let me just do length of pages. So it will show you the total page available. So you can see it's 16. So there are 16 page PDF, and then we're going to chat this particular PDF, right? So for this, once we have taken the PDF, once we have splitted the text into the chunks. I think no, we didn't split it up into the chunks, but yeah, we split the PDF into different pages. Now we are going to take or load the generative AI embeddings from Google, from Langchain Google Gemini. So this is the embedding that we're going to use. But before using that embedding, we have to split the text from each of the pages into the chunks, right? So that's what I'm trying to do here. I'm going to use recursive character text splitter. I'm going to specify the chunk size. You can also mention an overlap between the two chunks, so you're making sure that the context from first chunk to the second chunks, there's some information that is very available to both of the chunks in common. So you're trying to make a context aware chunks so that you are able to make sure that LLMs are able to grab the information and doesn't lose the context from the first chunk that is not available for access to the LLM, right? So that's where the chunk overlap is available to use. So let's say I'm going to mention like 1,000. There should be 1,000 chunk overlap, and then I'm going to pass it, and then I'm going to do it for each and every pages, and then I'm going to split that text into different chunks and with a chunk overlap. So once that is done, I am now going to use the Google Generative AI embeddings. And if you go into Google Generative AI embeddings, you're going to see this model slash embedding 001. So this is text embedding model, and you can also utilize it using generative AI embedding, using generative AI library, and then you're going to pass it using the API key, and this embedding model is ready for you. So once this is ready, your text, your PDF has been chunked into different documents, and your embedding model is ready. Now what you have to do is you have to just use your vector database, that is Chroma, and you have to pass all your text or your chunks with the embedding model, that is what you're using here, and then embed it inside the vector database. And you're mentioning that this vector database, you're going to use it as retriever, and you're mentioning that while doing a similarity search, you're going to just return the 5 documents, not more than that. Maybe you can play with it. We can mention 2 or 3. So I'm just going to mention 5, and let's run this cell so that it takes all the chunks and embed that all the chunks into the vector database, and this settings, right? So this vector database is set up. Now what we have to do is we have to just set the retrieval question answer chain type. So from here what we are going to do is we are going to take this retrieval QA, and we are going to mention the model. So that is the model, that is the LLM model that we are going to use, and then we are going to mention vector database, which is what we call retriever, and we are going to also mention that return source document is equal to true, which will return the similar documents that this particular chain is going to return in a form of search. So it should return all these 5 documents, similar documents, to the query that we're going to mention. So I'm going to mention a query which is what we call describe multi-head attention layer in detail. So this transformer models are made up of encoder, decoder, and inside encoder, decoder you have multi-head attention layer for self-attention awareness, right? So I'm just going to ask this question and pass this question to the as a query in QA question answer chain that we have developed here, and what it will do is it will just go into this vector database. It will search for the top 5 chunks, and then those top 5 chunks will be passed into the model, the LLM model, that is Gemini-pro, that you have described above here, and this model will return an answer back. So let me just run this cell, and you will get to understand what is the output that this particular model will generate. And then after this we are also going to see what are the source document that it has taken for this particular question to answer. So let's also visualize this in a better way. I think it's not very clear here, so let's use markdown to visualize our answers in a better way, right? So this is how the answers has been given by the retriever using RAG, and you can see it is able to give the answers in very detailed way, which I have asked directly from the RAG application to help us, right? And you can see the source document that it has used. Let us see. So you can see it has used all of these source documents or the chunks. These are top 5 chunks that it has retrieved based on the query, and it is trying to answer it based on these chunks. So now this is one of the way that you can use. You can see I haven't mentioned any uh, I haven't passed any prompt template to this. We just use the query and the retrieved closest documents based out of this query, and trying to answer back the results using LLM, right? Now what if I don't want to use this way, I want to use or pass a custom prompt, then I can do also that by defining the template. So you can see I'm defining a template. Use the following piece of context to answer the question at the end, and if you don't know the answers, uh, just say that you don't know the answer, and and don't try to make up the answer. Keep the answers concise as possible. Always say thanks for asking at the end of the answer. So this is the prompt that I'm trying to make up, and I'm also passing this context, and also giving it a question, and I'm trying to make sure that this will return an answer. So this is a prompt, a custom prompt, and I'm going to wrap it up with prompt template dot prompt template, and pass this template to this, and will this particular function will wrap up this prompt template in a Langchain acceptable format, and then in the retrieval QA, where we have mentioned model and retriever type, and the return resource documents, I'm also passing this prompt that we have used, that we have constructed. This is a custom prompt, and what it will do is, so when you're gonna run this the same query. So let me just run this, and so what will happen here is, when we're gonna pass this question to this particular retrieval QA, then it will generate some similar top 5 documents, and it will pass this as a context with this prompt and with our question, and it would return the answer back. So now let's see what is the difference, since we have mentioned that this particular answer should be very concise, and if you don't know the answer, just return I don't know, right? So let's see what it has written. You can see it has written very concise answer. So let me just use markdown to show you the answers. You can see it has become a very concise way of generating the answers. Now you can see it hasn't produced the answer that essentially it has produced above. So let me just scroll up, and you can see it has some different output, but now essentially, since we provided this particular context, so now it is unable to produce a similar kind of output, right? It is very different. We can also play with this prompt template. You can also mention uh, I think it should also mention thanks for asking. um, yeah, you can see here this prompt is working, and the model is able to return thanks for asking, whatever we have mentioned, right? So you can also write something about this particular document. You can also write something like concise this, or you can put a summarize this question, and then you can generate the different output based on the prompt template. So let's see the case where we randomly put some question, and let's see how this particular retrieval QA will be able to answer it or not. So you can see I'm trying to question describe random forest. So we know that this particular paper is all about transformer. It shouldn't be mentioning any of the random forest. So essentially it should return I don't know. I don't know the answer. So let's see how does this particular RAG application works in this case. Ideally it should fail. So let's see how does it work. You can see the RAG application is clearly able to say that I'm sorry, but this context doesn't mention anything about the random forest, so I cannot answer this question from the provided context. Thanks for asking. So I think it is pretty much doing good, and we are able to restrict this particular model by using this prompts. So let's say tomorrow if you're going to build an application, and if you don't want the model to answer it from its own knowledge or its own knowledge base, you can build such kind of prompts and utilize with retrieval QA chain, and you can restrict the model to not generate an answers apart from the context that you have provided. So that will bring a more nuanced or more advanced answers to the users that the user is looking for. He will not be able to question random things which is beyond the application that you have developed. So it will be the questions will remain and the answer will remain according to the context of the applications that you are trying to build. So these kind of prompt templates gonna help you to develop with this Langchain, and you can also utilize this Gemini with this Langchain, right, using this concept. So I hope you have enjoyed this particular video, and if you like this particular video, do subscribe my channel. Thank you.